Hello, everyone. Good morning, good afternoon, or good evening, wherever you are. Thank you for joining us again for day 2 of Linux App Summit. We are very excited and very happy to give a warm welcome to Rohan, who will be starting off our day today. Rohan will be talking about Linux graphics, and I hope you enjoy his talk. Rohan, welcome.
Hey everyone, can you hear me just fine?
You're a little bit soft.
Just a second. Is that better?
A bit, yes, thank you.
All right. I'm just waiting for the clock to hit 9 o'clock.
No problem.
All right. Hey everyone, I am Rohan. I'm going to be talking about the Linux graphics stack. I'm a consultant software engineer at Collabora, and let's get started. So before we get into this presentation, I am not yet an experienced graphics developer, and I would recommend that you take my words with a grain of salt and let me know if I'm wrong. So since we're at Linux App Summit, the core takeaway from this talk for you as application developers should be an understanding of how the Linux graphics stack works and the various components involved in the graphics stack. And as an application developer, how can you help debug issues while developing your applications on this stack? This presentation is not going to be about how to use graphics APIs or explaining what GPUs are or how to develop a GPU driver. That's kind of the big agenda that I'd like to kind of talk about here. All right, so the Linux graphics stack has essentially 3 major components to it. As application developers, you will be interacting with the graphics APIs, which are the first component. Underneath the graphics APIs are the GPU drivers, which are split into user space and kernel space. Within the Linux ecosystem, the graphics API implementations, as well as the user space drivers, live in the Mesa 3D software project, whereas the kernel space drivers live in the Linux kernel. As application developers, you will most often be interacting with either in the Linux ecosystem, you will be either interacting with OpenGL or the Vulkan ecosystem. On the Windows system, for example, you would be interacting with Direct 3D. I'm not going to be talking about that. So the graphics API. So what exactly does the graphics API give you? A graphics API is an entry point for graphics applications and libraries. It allows for abstraction of the GPU pipeline configuration and manipulation. Part of this pipeline is programmable, and part of this pipeline is configurable. And you have the choice of either OpenGL or Vulkan on Linux ecosystem, in the Linux ecosystem. As I mentioned before, part of the pipeline is programmable. And the way you program this pipeline is through either GLSL or HLSL. And these programs are passed as part of the pipeline configuration and are compiled by the drivers to generate hardware-specific bytecode. These are the use-based drivers I talked about just a couple of slides ago. So there are 2 philosophies when it comes to the graphics APIs. One of them is OpenGL, and the other one is Vulkan. OpenGL is the more traditional way of doing things, where it tries to hide as much as possible about the GPU internals, whereas Vulkan provides much finer grained control. Essentially, what this leads to is that Vulkan applications are much more verbose and more work for the developer, but less work for the CPU. This leads to better performances on CPU-bound workloads. This also means that Vulkan drivers are a lot more simpler. So since GPU is a fairly complex piece, the drivers for them are fairly complex as well. And not all of the code that you need to run on a GPU needs to be run in a privileged context. For this reason, we split the code between user space and kernel space. This also leads to easier debugging, since debugging in the user space is a lot more easier. So first, I'm going to be talking about the kernel drivers. There are a couple of responsibilities that the kernel driver deals with, such as memory, command stream submission and scheduling, interrupts, and signaling. These kernel drivers with open source user space drivers live in the Linus tree, and they are in drivers GPU DRM. Whereas kernels with closed source user space drivers are out of tree. So the first thing that kernel GPU drivers need to deal with is memory management. In order to perform memory management in the kernel, in order to perform any sort of graphics related tasks in the kernel, we have something called the DRM framework. Within the DRM framework, there is a memory management framework there are a couple of memory management frameworks called GEM and TTM. Before we get into GEM and TTM, there are a couple of terminologies that I'd like you to be comfortable with. A buffer object, for example, is a region of memory to upload GPU data, such as textures, vertexes. Just treat it as a region of memory, essentially, for now. An ioctl is the most common way for applications to interfere with device drivers. And a command stream is a set of commands compromising a full job on the GPU. Everything good with that? Everyone good with that so far? All right. So TTM is the older well, TTM is only used by one GPU driver that I'm aware of, which is VM graphicsware. Most of the kernel GPU drivers will be using GEM. So that's the only one I'm going to be talking about. So GPU drivers using GEM expose ioctls to do memory management tasks such as allocating buffer objects, releasing buffer objects, mapping buffer objects into GPU memory, and so on and so forth. They also provide a way to do cache maintenance, and they also guarantee that buffer objects referenced by a GPU job are properly mapped on the GPU side of things. On the right, you'll see a couple of examples of these ioctls. So you can see there's one which creates buffer objects, maps buffer objects, and gets the buffer object offset, or the offset in memory, essentially. The next part of a GPU, the next responsibility of a GPU driver is scheduling. Typically, when you submit a GPU job, it does not mean it will be executed immediately. There might be several processes using the GPU in parallel, and the GPU might just be busy when the request comes in. So essentially, submission means that you queue the command stream, and each driver has an ioctl for that. Since these jobs can have inter-command stream dependencies, and the user space driver knows those, the kernel space scheduler needs to know that as well. And DRM provides a generic scheduling framework called DRM Shed, which allows you to pass that information from user space to kernel space. So now that you have your memory, now that you have your job submitted to the GPU, how do you synchronize between the kernel space and the user space? What happens essentially is on the GPU side of things, an interrupt is fired, and this interrupt gets reported from the kernel space into user space. In order to propagate this information from kernel space to user space, we use sync objects and fences. Fences allow for one job to wait on another, and sync objects allow for user space to be notified when a job has been completed. All right, everyone get so far with the kernel space side of things? If you have any questions, let me know in the chat. All right. A couple of questions coming in on the shared notes. I'll just wait for them. Right, so command streams are submitted. So the question is, how is the command stream submitted? Does it also live in a buffer, or is it sent via ioctls? So the command stream is submitted via ioctls. Essentially, there is a structure that you fill out with a list of commands and submitted via the ioctl to the GPU, to the kernel, which schedules it on the GPU. All right, so moving on to the user space driver, a couple of roles of the user space driver are exposing one or several of graphics APIs, such as OpenGL or Vulkan. It also which involves maintaining the API-specific state machine, managing any kind of rendering context, compiling shaders, the ones that we just talked about earlier, which are written in HLSL or GLSL into hardware-specific bytecode, creating and populating and submitting command streams, interacting with the Windows system, and synchronizing on render operations, and essentially most of the functionality that you will end up using in user space. So there are a couple of graphics APIs that are provided by Mesa. So the first one is OpenGL, and it provides a front end for OpenGL and GLES. The modern day drivers make use of something called Gallium, which is a state tracker within Mesa, and the drivers are shared libraries that are loaded on demand. Whereas when it comes to Vulkan, Kronos has its own driver loader that is open source. Mesa only provides the Vulkan drivers, and there are no abstractions for Vulkan drivers or state tracking, and code sharing is done through libraries. So let's get into Mesa state tracking. This is the pipeline configuration part of the GPU pipeline. I'm not going to be talking about pre-Gallium days. A bunch of drivers such as i965 and i915 use this, but they are more or less on their way out in favor of Gallium. So what exactly is Gallium? Gallium is a state tracker that allows for tracking OpenGL state and allows for easier driver development, essentially. What happens is that Mesa will implement the OpenGL on top of Gallium, and Gallium consumes functionality provided by device drivers, which further consume functionality provided by the kernel space device drivers. This allows for much more easier creation of command streams and jobs, as well as making sure any buffers that need to be synchronized get synchronized properly. And it takes off a lot of work out of developing a driver. When it comes to Vulkan, Vulkan doesn't have Gallium. It only simply interacts with the kernel space drivers directly. All of the state tracking, for example, will be left to an application developer. Right, the next part is the Mesa shader compilation part. This is the pipeline manipulation part, or the programmable part of the pipeline. So shader compilation usually follows a couple of steps. What it essentially means is that a language such as GLSL or HLSL gets converted into a generic IR. This IR gets optimized by Mesa over a couple of passes, and then this generic IR gets converted into GPU specific IR, and then the GPU driver performs optimization in the GPU specific IR space. And then we have the bytecode generation, which essentially compiles this GPU specific IR into bytecode. So what does this actually look like? Kind of like this. So let's say you have a GLSL program, and the way it will work is that the GLSL will be converted into GLSL IR or SPIRV, for example. This GLSL IR will then be converted into TGSI or NIR. And between each of these passes, there's also an optimization pass going on. So once you convert GLSL into GLSL IR, it'll have an optimization pass. And then if you convert it into NIR, it will also have an optimization path. This NIR then might be converted into Midgar IR, for example, by the device driver itself, which will then be further optimized and then finally converted into bytecode. This is one of the most tricky parts of writing a GPU driver from what I've seen, simply because on GPUs such as the Mali GPUs, there's practically no available documentation on how to convert this NIR or intermediate representation into GPU bytecode. This is where the bulk of your development efforts get spent on, essentially. It also has a big impact on driver performance. So we really want to make sure that the driver, like this bytecode compiler, is as optimized as it can be. So debugging tips. As application developers, this is probably one of the most useful parts of the presentation for you. So GDB user friend, get comfortable with it. Essentially, if you've done any sort of OpenGL programming in the past, you will recognize that there's something called GL get error, which allows you to get errors from the OpenGL implementation. Within Mesa, this is implemented with the _Mesa_error function. And if you essentially break on this function, you will have a backtrace of exactly where Mesa stopped executing, or where exactly Mesa threw an error. If you use a particular GL function, such as GLGen textures, the equivalent Mesa function for that entry point is _Mesa_foo. You can break on any of these functions to start stepping into the Mesa implementation of a GL call. While you're debugging, enabling asserts is also a great way to ensure that all the conditions are being met and satisfied in the code. You can also set the Mesa debug environment variable, and you can check out every single driver has its own environment variable for debugging as well. And I would recommend that you go to this to the link that's mentioned in the slides for a complete list. Piglets. The piglet tests are one of the best ways for you to, as an application developer, to either understand a particular feature or a GL call. Piglet tests. Mesa has a comprehensive piglet test coverage, and simply using GDB on one of the tests and breaking on any of the functions that you need to debug or understand is a great way to have a minimal test case or a minimal entry point, essentially. All right. So the GPU topic is quite big and it can be intimidating. I have been working on this for the last year and a half, and I still definitely am learning. I still definitely have a lot to learn. So I would recommend that you start small and choose a driver and stick with it till you understand large parts of it or the larger theme of the driver. Maybe find a feature that's missing or buggy and just don't give up. Just keep at it and come hang out with us on IRC, ask questions. There's a whole bunch of nice people who will help you and try to kind of get things working. Things take a while, but if you just keep at it, you'll do great. These are a couple of good resources that I would recommend that you read to just get a general overview of how OpenGL works or how GPU works, or to get a better understanding of the DRM framework in the Linux kernel. And also go check out my colleague's talk at ELCE. There's a whole bunch of talks that come out at ELCE that are great resources to learn specific things about the GPU driver community, I would say. So go check those out on YouTube. And that's it from my side. Does anyone have any other questions? All right, so one of the questions is, which bit of the framework is responsible for shaders and where do they get injected? So shaders essentially are programs that application developers will write. Let me see if I can go back a couple of slides. All right, so shaders are written at the application layer over here, and they get passed to Gallium, and then they get passed to the user-based drivers. And these are essentially programs like they're C-like programs, and they get compiled just like you would compile, for example, a C program. They have a compiler, and except in this case, every single driver has a compiler. There isn't a standard GCC compiler. And in order to compile these programs, you first have to convert them from this C-like format to a IR format, such as NIR or TGSI. Does that answer your question? Awesome. One of the other questions was, I think someone asked, why are NVIDIA drivers so buggy? Jonathan. I have no clue. I think writing GPU drivers is pretty difficult, especially when, as a company, you have to support a wide range of products across a wide range of platforms. We, as Mesa developers, have a slightly easier job that we only have to kind of support Linux at the moment. And the fact that we have such a large and active community also definitely helps. I think if anybody kind of wants to come join us in the Mesa world, they should definitely come do that. Maybe we can learn from each other. So the next question is, what is the status of Vulkan integration in Mesa? Let's see. So that's a tricky question to answer, essentially because of the fact that there are new standards coming out. Every single time you have a new OpenGL standard coming out, there is new functionality that needs to be implemented. So the answer would be, it's never going to be complete. And so at the moment, I don't really know what percentage of the tests are passing, what percentage of the Piglet tests for Vulkan are passing. That is something that I would need to go and look up. But from my understanding, it is in a pretty good shape. I've definitely seen games running on Vulkan on Linux. So decently complete, enough to run a game complete.
Thank you so much, Rohan.
All right. You're most welcome.
We still have a couple more minutes in case anyone wants to add another question. Otherwise, thank you so very much, and I hope that you enjoy the rest of the conference and you're able to stay and watch with us.
Absolutely. And if you have any more questions, I am Shadeslayer on IRC. You can throw those questions over there. We have a bunch of IRC channels. Come hang out with us.
Great. Again, thank you, Rohan. We always look forward to hearing from you. Have a great rest of the day.
Good morning, everybody. Alison, can you check that everybody that
Hi,
you can hear?
yes, you beat me to it.
Wonderful.
Good morning, good afternoon, good evening, wherever you are. And I'm very pleased to welcome Luis to the stage. He's going to talk about MyGNU Health, which is an ongoing project using open source technology. Everyone, please give a warm welcome to Luis.
Hello, everybody. Good morning to you and good afternoon, wherever you are. Today we're going to be talking about MyGNUHealth. It's a Libre project for a personal health record, and it's part of the GNU Health ecosystem. Just to go through the agenda very quickly, we'll go through the history of the project, and then we'll talk about the components. And finally, we'll dive into the application itself, the mobile application. And this is a bit more technical than others, but not too techy anyway. So I think that everybody will be able to follow it. And hopefully, I think that we have until 9:15, 9:20. So we get some time for the questions if there are any. Just a little bit about myself, my background, academic background and professional background. I'm a computer scientist and a medical doctor, and basically I've been specialized in genomics and medical genetics. But the things that move me the most are social medicine, animal rights. You might hear my dogs between the talk calling me for a walk, and of course Libre software. And it's a great combination to work in the three of them in these sort of projects. So this picture was one of the very first one that we took in Argentina. This is 2006, and it was the initial or the kickoff of the GNU Health project. We were working initially in rural areas, schools, and then I felt that these kids needed more than just technology, and that's where the primary care concepts and the public health and all these socioeconomic determinants of health came into light. And a couple of years later, GNU Health was a reality. So GNU Health is a project from GNU Solidario. GNU Solidario is an NGO that works on social medicine. And we have a global, we're a small NGO, but we work globally. We have projects in all continents today. And it's also a GNU official project since 2011. These are just some very quick summary of different projects around the world, from Laos, Jamaica, Argentina, Mexico, India. And we work with multilateral organizations like the United Nations University or the World Health Organization. So what's taking us today, it's again MyGNUHealth, and as I said at the beginning, it's part of a larger project called GNU Health. These are some of the components, technical components that we use in our project. All of them, of course, are Libre software, and from operating systems as OpenSUSE or FreeBSD. Database, we use different, like PostgreSQL or TinyDB, Python as a main programming language. Qt, Triton, Flask, and the documentation today is on Wikibooks. We use Vue.js for the Federation portal and GNU-PG mainly for signing documents and encrypt documents. So GNU Health, as I said, it's an ecosystem. It's a set of programs that do different tasks. Okay, so we have health. Hospital information management system, we have a laboratory, we have, we'll be talking today, personal health record application. We also work on the areas of precision medicine and bioinformatics and genomics. And also we have the embedded solutions, so you can run GNU Health on single board devices like Raspberry Pi or Caras or Olimex. So from all of those components, we have this screenshot, this set of different scenarios within the hospital management information system component or node. I call them nodes. So you see that you can do diagnostic imaging, have your agenda, work on histopathology. You have charts for epidemiology or growth charts in pediatrics and so on. And basically, you can run your health institution, your hospital, your primary care center, or your private doctor office or laboratory. So now let's get into the details, or more than details, an introduction of MyGNUHealth and why did we create this application? Why are we creating this application? The main idea behind MyGNUHealth is putting the person, the citizen, the patient on the driver's seat, right? I feel like as a physician, most of the time, the people or the patients are more of like passive actors, you know, and they pretty much are supposed to take the orders or the recipes or whatever the health professionals tell them, and that's a mistake. We have to empower the person to be an active member of the system of health. So within this GNU Health ecosystem, MyGNUHealth uses this technology that you're seeing here. Okay, so as in many other components, Python is the main programming language. We use again GNU-PG for privacy and for signing documents. In this case, we are using TinyDB as a document-oriented database, because remember, this is now a one-to-one relationship between the person and your database. This database is not a multi-user DB. This is your DB. It's going to be on your desktop or on your mobile device with your only data. Then we'll see Kirigami, that makes it convergent, Matplotlib for charts, and Qt for all the framework of the graphical interface. We use a Plasma Mobile. So Python 3 is the main language, as I just said, and most of these components, you can find them today at the Python package index, PB. And again, as many others, okay, so you can find Thalamus, or you can find all this stuff related to bioinformatics at PyPy2. So we are using Qt for all the graphical interface. by using the PySide package. Okay, so basically it's the Qt for Python or PySide 2 package that allow us to interact with all the Qt classes already existing, and it's rolling out really well. Now, one of the good thing about Qt and KDE framework is this component called Kirigami that allow us to make MyGNUHealth convergent, and that means that it will adapt to different scenarios. So if you are running MyGNUHealth at your desktop computer, you will have your widgets and your UI adapted to that desktop computer. Now, with the same code, you will be able to run it on a mobile device, whether it's your tablet or whether it's your mobile phone. So here is a very short example of MyGNUHealth PY, the very first or main program, and you can see in this slide how you actually import those modules. So you have PySide 2, Qt widgets, Qt core, and Qt QML. We use QML for the design, and the logic is always on the Python side. It's a nice way to divide UI from the logic, and it's pure Python 3 code. So this is an example on how it will actually be seen on the Plasma desktop. You have two screenshots from different contexts, right? And you will be able now to see in the next slide how it actually look on the mobile devices. So this is actually a picture, a photo that I took from the Pine phone, and again, you know, I didn't have to change a single line of code thanks to Kirigami framework, right? If you see this slide, you will see this little icon here, the typical X from the X Windows system, right? And of course you have the Windows frame and so on. And then when it comes to the PinePhone, all of those frames and icons disappear for the sake of expanding, right? And optimizing the viewing experience and the layout on smaller screens, and it works really nice. Now, a few words about the storage. So one of the things that we need to do is to be able, of course, to storage all this data. If we want to have a chart on my blood pressure or on my blood glucose levels, I need to be able to retrieve it from somewhere. And of course, there are many really good databases engines, both for regular computers as for smaller devices. But I also wanted something that it was going to give facilities to the end user in terms of searching for documents, and be able to make a single backup and take it from your desktop to your mobile and vice versa and so on. And that's where I found TinyDB. TinyDB, it's a document-oriented database. It's basically a nice way to represent JSON and to store JSON objects. And it's of course platform independent. That means that if I take that dump from my desktop, I'll just take the file and I can just put it on the tablet or on my mobile device, and it will just work fine. And that makes it very portable, and so far so good. It's a really nice document-oriented database that for this case, where we don't have much of concurrency at all, it's basically a single-use database. It's working beautifully. So now we've talked about pretty much running my GNU Health, my personal health record on my devices, right? Whether it's my laptop or my mobile device and so on. But that is good, of course, that is great, but we need to go one step further. And that means we need to integrate this data in the system of health. So my health professional can see all those results without me having to go to the health institution. And especially now with this pandemic context, that comes very handy, because then, you know, you can have pretty much a daily, or your daily activities being monitored by your health professional, and you can take action, or she or he can take action depending on the values that you are providing. And that's where the GNU Health Federation comes into place, right? If you see this slide, you will see that it has pretty much three sections, right? You have a left side with three icons. Then in the middle, you have thalamus. And then in the right side, you have the GNU Health Information System. Well, the components that you see on the left-hand side, those are the nodes that make up the GNU Health Federation. So one of the nodes can perfectly be a hospital, running the hospital management information system node from, GNU Health. The other can be a laboratory, and the other can very well be my GNU Health, right? So this could be my GNU Health application. What happens is you are going to have the possibility of setting up my GNU Health and saying, well, I want to be part of the system of health, right? So you have a network settings that we'll see a little bit afterwards, where you can actually say, well, this is where the thalamus server it's located, and I want to provide my credentials, so whenever I enter my data, that can actually sync or be in sync with the with this very large database that we'll have on the public health system, for example, right? So the thalamus is pretty much a message and authentication server that it will allow you to go and put data and retrieve data depending on your access rights, right? So basically you have an ACL that says, well, you can actually providing that you have logged in correctly, and you can do this and this and this on this and that resources, right? And the thalamus it's pretty much a Flask application, right? So this is just to show you how you can couple with the GNU Health Federation from your own MyGNUHealth application, right? So in this case, you would go to network settings, right? And then you establish by default the SSL HTTPS protocol. Then you put where is that Thalamus servers. In this case, we have in Germany, this is the Federation GNUHealth.org. This is a public server that we have set up so everybody can test their nodes and play around with the system. You put the port, and then you have your unique federation account and your password. Right? So what is the federation account? Well, this is something that we actually introduced this concept some years ago already. And what we need or what we want to achieve with this is that no matter where you are in your province or in your region or in your country, your health data is going to be up to date. So if you are in Health Center A today and you go to Health Center B tomorrow in another province, whoever is going to see your clinical history is going to be updated. He or she doesn't have to start from zero to get all the data from you. It will be already there. And that is a huge advantage because, believe it or not, we are still in many places in the world and in many places within Europe where different provinces have their own local database and they don't talk to each other. So if you go from Madrid to Barcelona, you're going to start from scratch with your medical history and clinical history. And when that is within the public health system, where pretty much we have 7 minutes per patient, that takes precious time out of your visit. So once you have this set up, all the data that you put and you wish to put, because again, if we go here, but if we go back here, 1 second, you see this sync Boolean here field, basically saying, I want to be part of the system of health. Okay, and if you don't put the sync, and if you don't fill in this data, you have your data only for you, which is perfectly fine too. So this is, again, a bit of a summary of what I just said about the benefits of having every person as a node. So until now, the nodes were pretty much health institutions, okay? So you have many health institutions across your country, and yes, today we have the ability with the GNU Health Hospital Management Information System to sync all your patients' evaluation, lab, clinical diagnostic imaging, and so on. But we didn't have a tool that would make the person an active actor, right, in the health system. And that's where MyGNUHealth comes into play. And that's where you now as a citizen are a single node. Now, all of this is really great. But if we look at it not only on the COVID pandemic, which of course will make a huge difference, and it's already making it in some countries, not at MyGNUHealth, but at the Hospital Management Information System. Think about what we can do in rare diseases, in cancer research, in autoimmune conditions. There are so many things that we can do in the fields of precision medicine with the GNU Health Federation that is incredible. And you can only do this if you have this sort of federated database and this federated distribution. We work with the UniProt databases and the UniProt team, and we have thousands of natural variants and proteins, or basically mutations in genes that today we are uncertain of what is the clinical significance of many of those mutations. So some of them we know, and yes, we can say, well, this is non-pathological, or yes, this is a clearly pathologic mutation, so it has a very important clinical significance. But many of them, we just don't know what can happen to us if we carry that mutation with us. And by having this sort of infrastructure, you can find, or it will help us finding a correlation between your genotype and your phenotype. So what are your genes and what is the expressions of those genes? And for those, especially for those mutations where we still, or natural variants that we still don't know what is the clinical significance. And this would be really a breakthrough. And we are pushing to have GNU Health and MyGNUHealth in different countries around the world. Of course, we already have that. But now that we are in Europe, we want the European community to embrace MyGNUHealth and MyGNUHealth Federation to tackle these genetic diseases and of course, cancer research. And in Argentina, for example, the national agency for research has chosen MyGNUHealth to work on as an observatory for the COVID pandemic in the Entre Rios province. And again, this possibility or this ability of the MyGNUHealth, of the GNU Health Federation to be able to do real-time charting, real-time epidemiology reports, in many cases will stop an outbreak from becoming an epidemic, right? And it would be great to have had this in the early times of the COVID. But anyways, it's there, and it's available for any public health system in the world that wants to use it. And we are not just talking about infectious diseases. There are so many other diseases that are not contagious. So we are talking about diabetes. We are talking about domestic violence that are as important as the contagious diseases, and we need to tackle them in the same matter. So just wrapping up, some of the things that we are doing today and some of the things that we need to be done or need to be where we need to put the focus. Again, as I said, currently we have the the Mercurial repository at Savannah, GNU. And the documentation is on Wikibooks. We are supposed to be releasing a beta version by the end of the year. And things that we would like to work on, of course, packaging, localizations. We've done a pretty good job on localization with the hospital management information system, but today MyGNUHealth is in English only, so we'll have to work a bit on that. So no matter where you are, you will have it on your own language. Of course, strengthen privacy and security, making sure that everything is in place. The difference between MyGNUHealth and the hospital management information system node is that MyGNUHealth is to be run by people that not necessarily is technical. So everything should be very, very simple to use. And as a matter of fact, MyGNUHealth should be already installed in, for example, the PinePhone. So whenever you get the PinePhone, you will have MyGNUHealth in place. That would be wonderful. And if not, it should be simple to just download as a regular package. Oh, by the way, we, or at least I, work only on Libre operating systems and Libre devices. That's why I have chosen the PinePhone as the first mobile device to install or to develop MyGNUHealth in. I don't work with Android. I don't work with iOS. I don't work with Microsoft Windows. Those are non-Libre environments, and I don't really want to spend my time on those. If anybody wants to port MyGNUHealth to any of those operating systems, you are most welcome. But I think that it's not part of the GNU Health philosophy. GNU Health is a social project that that uses technology, but mainly is a social project. And I think that anything that is non-Libre goes against our philosophy of universal healthcare, and it's putting some sort of bars in front of people to reach that universality and that freedom in healthcare. That's why, again, I only work with Libre operating system and environments. As I said a couple of slides before, we have a testbed. We have a community public server in Munich where anybody can just log in and play around with it. We have a Thalamus installed there, and we also have the hospital management information system. So you can log on, create a patient, check the the lab test, imaging, and also play with this concept of the federation. So you can install your own node and start syncing information back and forth and so on. So that should be running 24/7, and it's been there for quite a bit now. And next week, right by this time, we will start the GNU HealthCon 2020. It will be also online as the one that we are doing today at the Linux Application Summit. And you are most welcome to participate on it and to get in touch with the community, see all the guys from Qt and from the Plasma Mobile and from the OpenSUSE and so on that will be there hanging out with us and giving out a lot of cool information that definitely will be in the next upcoming GNU Health and MyGNUHealth releases. So remember, this will be next Friday, November 20 and November 21st. Friday and Saturday. And you are most welcome to register right there at www.gnuhealth.org. And that pretty much makes it for today. This is just some information. I will leave it there for you. So if you want to get in touch with us, we'll be very happy to listen to your questions and comments, which of course are very valuable, because at the end of the day, what you see today, it's a 12-year project and 12 years of feedback from the community, which have given us the success that has GNU Health today. So yeah, we're going to have like 8 minutes if there are any questions.
Yeah. Thank you, Luis. We do have some questions. If you would like, I can say them for you.
Great. Yes, please,
Awesome.
Alison.
We have a few minutes, so let's get started. The first question is, what challenges does this app pose on terms of privacy?
Yeah, well, actually, one of the reasons that we create MyGNUHealth is actually to empower the person and make sure that you are in charge of your own privacy. And that's why we don't use any operating system or any device that is non-free, because you are going to have the source code, you are going to have the possibility of encrypting your data, and you are going to pretty much be in charge of your own data. And if you want to be part of the GNU Health Federation, you might be very well welcome. But from start to end, you are in charge of your own privacy. That's what it makes it different from other personal health records. And that's why actually one of the main reasons we created MyGNUHealth.
Okay. The next question we have is, what are the open hardware devices you are currently looking at?
So we have, we basically have the PinePhone on mobile devices, but then we have the CADAs, and we have Olimex as single board devices. And we also have images for the Raspberry Pi 3 and 4. So those would be the open hardware technology. I would say that from all of those, CADAs and especially Olimex is really, really from A to Z open hardware. It's a great, great device.
All right, the next question we have is, regarding privacy, who has access to data on Federation and how?
That the access to the data on the Federation, it's ruled by the access control list that you have on your Federation ID that I talked previously. So if you are a citizen, you will have a citizen profile. If you are a health professional, you have a health professional profile. And if you are in the Ministry of Health, you will have a Ministry of Health for epidemiology and whatever profile. So depending on your profile, you will have different access control requirements to different resources.
All right, Luis, this is the last question we have. It is, how is duplicate data handled?
You shouldn't have any duplicated data, because every single message has its own UUID. It's unique ID. So you can have 2 different records with the same value, but those would be different IDs by itself. So every node has its own ID, and every message within the node has its own unique ID. So it's pretty much impossible to have duplicate data.
All right, Luis, well, thank you. It looks like that's all the questions we have. I hope everyone enjoyed your talk as much as I did. It's always great to hear from you. We are coming up on a 10-minute break.
Wonderful. Thank you, Alison. It's been a pleasure for me, and thank you for having me.
Oh, it's our pleasure as always. Luis, we hope we get to see you around the conference a bit more for the next couple days.
Absolutely.
Great. Feel free to hang out and chat. Your questions are still in the shared notes. As for everyone else, we are taking a 10-minute break and we'll be back shortly.
Excellent.
Good morning, good afternoon, good evening, and namaste everyone. My name is Rakshit Vaishnavi Dogra, and I invite E. Katrina Muraru, who goes by @Ivalika on Twitter, who will be giving us a splendid talk on UI UX tips and tricks for developers. I already follow the tricks and tips she gave us in FOSDEM 20. So, ladies and gentlemen, I request a huge round of applause for her. All the best, ma'am.
Oh my God, thank you so much for this introduction. I feel like, yeah, the audience is happy. Yeah, hello everyone, nice to be here. My name is Ekaterina Moraru, and I want to talk a bit about UI tips and tricks. I said that they are for developers, but I mean, they are for everyone. I mean, developers are just humans, right? But why do I think it's important to know at least the base things regarding the UI UX is because we have this I don't know, this approval inside our open source communities that the interfaces are not good enough and not enough designers are available to help with the projects we're working on. So I think it would be very helpful for any developer to know some basic when they're doing their interfaces. Personally, I work as an user experience designer, and I've contributed in open source for the past 12 years, and I would love to have more designers involved, I don't know, in making open source so much greater than it already is. If you have questions, please ask them when you have them. I mean, I tend to talk very fast, so yeah, if you have questions, just address them now. Okay. Sorry. Okay, so just like in programming, let me switch the slide. Just like in programming, we also have some patterns in the user experience field. The patterns can be, I don't know, it depends very much on the platform. I mean, there are some patterns for web and for mobile, but the patterns are considered to be, let's say, the next level. In this presentation, I'm going to go even lower and even basic, just like learning CSS or learning the algorithmic part of in programming. And we're going to cover some of the principles. And principles are just fundamental rules about the practice of design. And there are many principles. I'm kind of mixing principle and examples in my presentation, but the biggest principle that everybody should try to apply in the interfaces they are creating is consistency. And I don't know, as a beginner, you should make that your main rule, that everything needs to be consistent. If you go to the advanced level, let's say, there are some corner cases where consistency can be broken, but in majority of cases, if you stick to the consistency rule, then you'll be on the safe side for the majority of things that you're doing. And what exactly it means to be consistent? It means that similar objects should have similar meaning and function. If something behaves in a certain way, user learns that once, and then he will know that thing or object will behave the same next time. When consistency is broken, we have that confusion moments, and the users are not sure what exactly happened. And also, it would be very nice, I mean, to take the same principle or things that we see in the surrounding world and apply them in our interface. I mean, if we see that everywhere on the applications, when you click on the logo, it takes you to the home page, you should do that also in our applications. I mean, having a consistency inside an application is great, but having consistency across multiple websites and software is even better, because the user don't need to read any of the manual. Okay, and consistency, as a principle, can be applied to anything, starting from buttons and continuing to all kinds of UI elements. And even if the buttons need to be consistent, there are several types of consistency we can apply. I mean, it doesn't mean that you need to be consistent on one type. I mean, there can be consistency in subtypes, and buttons can be split and should be split. I mean, if you split them, it's going to increase the usability. You can split the buttons into the two categories, like primary and secondary actions. I mean, when you have a page or a screen in your application, you should present to the user what is the main action, what is the call to action that you want that user to follow and to do on that particular screen. And there are several ways to do that, like, I don't know, like floating buttons, like, you know, the pluses that we see on the corner of our screen, or I don't know. But no matter how you decide to represent this, they should be marked with a more predominant color in order to attract the attention of the user. And everything else, all the other actions you have, present them as secondary actions. Sometimes there can be like tertiary, like, you know, like cancel, or like other things that you know for sure the user might not need, but have at least one primary action and represented in a very clear way. And when you represent this action, make sure that you are using verbs as action. We've seen a lot buttons that have like okay, or read more, or I don't know, even next can be ambiguous, but it would be so much easier for the user to know exactly what it will happen if he press that button. So using verbs helps the user do that, because users think in verb. When they are on a screen, they might want to add something or delete or edit, and not second guessing what that button does, or not needing to read the description text every time he does that will help them make that decision faster. Also, when we are writing hints or labels that help describe the action, make sure you are using natural language and not very technical terms. I mean, in open source, it's so often that you see concepts that are not explained to the user, and a lot of abbreviation and things that for the normal users, they not necessarily know what they mean, and that's why the interfaces can be perceived as scary. Regarding consistency, it would be ideal if you would also preserve the tone of the way you are phrasing the things, like being friendly and keeping the same tone everywhere. And I know this is very hard, because as developers, we are preferring so much to be efficient, and we know that just with one acronym we are saying so much more, but it's very important to know what is your target audience, and try to be empathic and put yourself in the other shoes, and think of the users that don't know anything about your interface. Okay, so I hope I won't see buttons anymore with okay or stuff like that. Button placement can also possess some issues and questions, especially for people that are not very comfortable designing interfaces. Sometimes we look for inspiration in some screens, and we see that I don't know, in some screens we see them on the right side or on the left side. If you are designing for devices, the manufacturers of the devices I mean, the operating system people are usually providing also guidelines and style guides on where exactly the button is to be placed. And unfortunately, some platforms prefer it one way and others prefer it the other way. But again, as long as it's consistent everywhere on that platform, it's great. But when you are trying to make the decision for yourself, maybe you are designing for web, and on the web, we don't have very clear rules or where to place them. What could help you make that decision is understanding the reading flow that the user does. So, for example, in the left align, the user could just read the title and maybe go directly to the button that is the action. So the flow can be very linear. But for example, I don't know, when we have confirmation dialogues, it's very good that we have them, and we should be very explicit of what are the consequences of that dialogue. But this means that the user should read what's stating. I don't know, I'm also deleting these records from the database, am I affecting something else, can I go back, etc. So the pattern the user does, it will read the text, it will read the description, and then it will go to the secondary button, and he could continue, because that's what we want them to do. He could continue on the primary button. On the left aligned side, he will need to make this going back in order to keep to make the action. So yeah, think about if you prefer to have the vertical scanning, or if you need this. But no matter what decision you make, you should make this decision only once and then apply it to all the forms and all the buttons across your interface. A note regarding mobile devices. Let's say, this screen, when it's either left or right, is not very important when the display is very little, because the distance from left to right is like, I don't know, 300, 600 pixels, depending on the resolution. And sometimes you can also see on the mobile devices buttons that are centered or that are full width, and put, I don't know, like vertical one after the other. So on mobile, it doesn't matter that much. But on the web, if we have very large displays, and for example, like here, we don't have columns. I mean, when you have larger display, you can group and split the content into multiple areas, each with their own layout. But let's say if you would have something like this, even let's say if you would have preferred the left alignment because of that faster millisecond, in this case it will not be that efficient, because you kind of lose the context between the text and the buttons. So yeah, you kind of need to know exactly what resolution you're designing, what are the cases, and sometimes it's okay to make some screens or reiterate, because it's not waterfall. I mean, we can see the screens after and go back in the interface and fix them and decide later, even though it's not very efficient from my implementation point of view. But I think it's better if we fix them later and improve the usability than the work needed to do that. Regarding placement, sometimes buttons feel more natural if they are placed on the right side, let's say in the case of wizards, but this depends very much on the culture you are designing for, and again, you need to know your target audience. I mean, in Western culture, we are reading the book from right to left, and we are reading from left to right, so it's natural for us to, I don't know, to make the same movement like the pages on a book. But not every culture reads this way, and I don't even want to go in the I don't know, Japanese or other Asian reading directions because they can also be vertical. But the point was here that for wizards, it feels natural to have next on the right alignment, but no matter where you place them, another tip that you need to know is that the primary button needs to be placed near the edges. I mean, you should not place the primary action in the middle. Think about the direction you want the user to go, and place the most important action near the edge because it will be much easier to be found by your user. Color as a meaning, it's very important, and it's very interesting to look at. I mean, I'm making a generalization here and it's not true, but I wanted to say that open source projects have a lot of blue, and it is great because blue means, I don't know, trust, and we want with our application, especially because they're kind of technical and kind of advanced, to inspire the user with trust. But keep in mind that colors, again, depending on the culture, have some meaning. And depending on the culture, it's again an important note because danger in Western means, and it's used for errors and I don't know, destructive actions and things that could go bad, while in Asia, red means auspicious and luck and all the good things. So yeah, think about that. And I mean, it would be great to, depending again on your audience, if you want younger audiences, you might want to use black. Oh, sure, we love black in open source, right? It looks more geekish, but I don't know, maybe you would want to use purple or oranges. Think about how other people are using, and I know we want to be different and we want to be unique, but sometimes people come with expectations of what they've seen in other places, and I don't know, maybe they expect some green sites and colors to be used by pharma or I don't know. In the branding part can be a lot of discussion. So sticking to the blue, it's actually a good point because I don't know if you can go wrong with that. But what I've talked until now is mostly of having like an accent color and a branding color that you can apply to the majority of your style guide. But in theory, you could have multiple colors for buttons. I mean, you can have like a success and warning and info. And if you were to use, I don't know, UI framework like Bootstrap or a library that provides the code already done, they usually provide this kind of specialty buttons. This doesn't mean if they are there that we should use them, and generally we should try to limit the color selection we are making. And another note about the color that I want to make, I mean, in this case it's very nice because it's a success and warning, but imagine that you would have like a word that it's ambiguous. You don't know exactly if it's a success or if it's danger, and you as a designer rely on the color, and that person that is viewing this screen might be colorblind or not necessarily identify the color and or understand exactly the meaning that you're trying to convey. Don't rely only on color. That's why a good practice is to, I don't know, put like an icon or try to make another shading or some background thing that can add to the diversification of the icon a bit more for the people that don't necessarily differentiate colors. And this is more related to accessibility, but it's good to have it as a mention. And why should we have destructive colors and actions? again, this might break a bit the consistency, the thing that we were talking in the first thing, but this can be a good thing if we are using it with caution. I mean, if we are consistent throughout the interface and users know that that button needs to be blue and they see that button to be red, they might say, okay, this is something special. Maybe I need to pay careful attention to it. And again, don't rely just on putting that color and making sure that users will know the consequence of their action. Always try to have a confirmation for destructive action, explain very well what they are doing in case the user is not able to recover things that they are deleting. You know, there are several patterns here, like even very not hardcore, I can say, but you know, when you were requesting the user to type the name of the folder they want to delete, or to really type delete, I mean, these are not necessarily good practices, but there are some ways to ensure that the user is know what they're doing. I would not encourage these kinds of things because they kind of increase the time to make that action. Yes, sure, the user will be very aware that he is doing something bad, but he'll also be very scared about ever touching that piece of functionality there. Ideally, we should provide support for undo, and it's so funny when as a designer you go to the developers and ask them for undo, and I mean the requirements to have this kind of functionality are so much difficult from an implementation point of view, but are so much nicer on the user side, and you always need to make this balance of deciding what side you want to make happier. Okay, and yeah, I mean, use them as blue because they should be consistent, but it's better if you put them as red. Affordance, it's a principle that is widely used and widely found, and it's so much nicer when it's well implemented. And the metaphor for understanding affordance, it's the doors. So if you want to open a door and it has like a circular handle, you might know that in order to open that door, you need to twist the handle. The same is when you see the door and it has like this handle, like vertical, and you can grab it, you might understand that you need to pull it, or if it's like flat, you know that you need to push it. The problem is when the affordance the door is giving you doesn't match with the behavior that door has, and that's why when you bang your head to the door and stuff like that. So affordance means giving cues on how the user should interact with the interface before they even pressed it. And it can be very good if the interface behaves as the user expects, and it can be not very bad, but it can be confusing and annoying and disturbing to the user if the interface does not behave like the user expects. And I provided here some examples. So for example, let's say that you have some headers and you put them in blue, but those are not actually links. I mean, if we were to go on a blog platform, the majority of them are links, and you expect to go there and I don't know, read the whole article or something. But if you make them blue and it doesn't do anything, you'll be like, okay, it doesn't do anything, you'll learn. And then you make again the mistake. So it will, every time you will have this, I don't know, battle inside you of what does it want from me. Another thing, the same is also for I mean, to differentiate links from the content. The user might not know that this is a link. It might say, I mean, in this case, it's very nice because it says details and the others you cannot read. But if it were to be a whole text and having only details at the end, you might not know that that's a link. So for the past, I don't know how many years, these blue things and blue links and underline links, it has been so much blurred because we have like now style guides of every other color, but some users still expect, and if we were consistent throughout the interface, if you will see some text that is blue and underlined, I'm assuming that that person will know that that's a link and will expect it to be a link. So differentiate the links from the content, and if you can make them blue and underlined, that will be a plus for the usability of your application. And one of the questions is, okay, when to use buttons and when to use links. And let's say maybe it's more obvious to not have buttons inside of the text, and not necessarily because it would, I mean, it will also look strange, but you will also have some line height alignments, and things will not look good or align good. But the thing you need to know here is that buttons and links have been created for a very specific purpose, and that meaning that buttons should be used for actions and things that affect the interface. I mean, I don't know, that add entry to the database, that changes the state of an object, while links were created mostly for navigating through next screens or to go other places. So use this thing as a rule when trying to decide what to use when. I mean, sometimes we prefer the look of the links. We think maybe it's a bit more light, but if you have everything as a link and they have different behaviors, this can also be a bit confusing. Another note that I want to make about buttons and affordance is that traditionally buttons have been displayed as 3D objects, so the flat trend kind of removed all the gradients and all the shadows, etc. But if you have some shadow on a thing, the user might know that it's a 3D. It can be clicked because buttons have very specific states of being pressed or being active or being disabled. So this kind of things could help the user know what to do exactly in the interface. Okay. Wait. I also want to present you some proximity, some other principle, and one of the principles is proximity, which states that objects that are closer together are perceived to be related. And this is very important, let's say, when you're creating an interface and you want to do some grouping. I don't know, you want to group all the menus together and you put them a bit separate, so the user knows those are related and the content is put someplace else. Or in the case that you have a menu and let's say that menu has like 5 independent things. If some of these things are related, I don't know, like in this example from Gmail a while back, if you have this, if that mail is important or not, you could put them more closely together to state that functionality is like comes in pairs. And it's so much easier to scan an interface where the things are grouped because you can just jump from one group to another instead of trying to go over each of them. So spacing can be used to provide this kind of grouping. And another thing to consider is the similarity principle, which states that object sharing attributes are related. So if, for example, you would try to read this by lines, let's imagine these were text or something, it will be so much harder than reading them by colors, because our brains automatically groups them by colors, by columns, and this grouping can be done using color or size or shape or orientation, or there are multiple ways in which we can do this grouping in order to help us navigate and browse. You know, when we have activity streams and we have the avatars, some avatars are displayed with circulars and we put them in the front, so the user just jumps from one avatar to another without needing to read, because he's expecting all the items there to be of the same kind. The law of unity is another principle that is kind of overriding cues from proximity and similarity, so it's much stronger in the effect it can have. And what it does is that if you provide lines, like in this case, or if you provide boxes, or I don't know, background colors or whatever, this additional container, it's grouping the things inside of it. So this can be very powerful. I mean, again, even if you would have like so many entries here, just by putting a background and a background color, it will group your form, and the user will know where to look, and that those things are grouped. A note regarding this is that we need to be very careful in order to not overcrowd the interface. The more lines you put, the more background colors you put, the more containers you add, might feel a bit heavy. That's why, in order to have that eerie and simple and clean look, designers are trying to add as much white space as they can, and try to limit at all these heavy things. But if used properly, it can be a very powerful technique in order to emphasize things. Choice paralysis states that if users are going to have lots of options, they will not know exactly which one to pick, and they will be paralyzed. I mean, is that good for me? Is not good for what should I pick? And Hicks' law states that the time to make that decision increases with the number and complexity of choices. So what is recommended here is to limit the options we are giving to our users. And I've seen a lot of download pages for our open source project that I mean, we are very proud that we are supporting so many devices and so many platforms, and we want to let the user know about that, but that can be very overwhelming. I mean, we can, I don't know, try to detect the operating system the user is on, and propose exactly what they need. And I don't know, even sometimes even for the same operating system, you have like different packaging methods. So state very clearly what are the differences between the types, and always recommend the one that you are proposing, because sometimes we have a preference what we want our user to try, and sometimes it's the servers. I don't know, depends on the project. So it's hard to make a generalization. A similar principle is the 7+2 rule, which was an experiment done by Miller like 100 years ago, and this psychologist investigated how many words can somebody put in their short-term memory and not forget. And the results then were like 7 ± 2 items. And this argument was used for a very long time in order to limit the things in menus. I mean, if you had like more than 7 + 2 things, it was outrageous and you needed to limit. Now, new research has been made and the estimate dropped to 4 ± 1, but there's not really a number that can be given because it depends so much on so many other factors. The conclusion here is that in our interfaces, we should recommend and provide as fewer options or try to group them or present them in other screens in order for the interface to look digestible. Yeah, I've seen so many sites, and sometimes we, in open source, we take pride in being very thorough and having all the information needed, but sometimes that can look so hard and so hard to digest. Okay, stereo position effect states that we remember best the first and the last item in the series. The example here is with the alphabet. We know it starts with A and ends with Z, but maybe in the middle some things get confusing for some people. And this can be also combined with the chunking principle that say that if you have a lot of information, it would be good to break it in smaller chunks. And in this case, instead of having a navigation that has like 9 items, just break them in smaller things. And for each of this group, you will have a first and the last, and the first and last will be so much visible than what's inside. Because sometimes we say, okay, maybe the most important thing, put them on the first position and second position, and that is great for things that are in a single line. But we can use this too if I don't know, we have multiple things than 2 that we want to highlight. For fields have a lot of things that can be given as tips of what to do. Chunking can also be applied to phone numbers because it's so much easier to remember things in chunks of 2 or 3, and you can also size fields accordingly. If that field is just 3 characters or you know the size of the zip code, just provide the exact dimension that you want the user to enter that information inside. Highlighting and explaining the error in the context that it occurs, it's so much better than having a generic place where you can look for the error messages, or how we've done it for our project. The user needed to look in the console to find out the error that happened on the server. No, it would be so much greater for them to have the error inside the interface. Numbers should be right aligned because it's so much easier to compare them by decimals and by hundreds than just having a random alignment for them. And this happens also, I don't know, you can mark things that are secondary information with another color and keep the alignment good so that people can compare the things that they are interested in. I'm trying to go a bit faster because I don't know how much time we still have. And we are closing, and I would want to see some questions. I see we have 2 questions. But as a closing note, I want to say again, I want to say some things about the icons. We are past the interface that are only text-based, and icons are very strong because users learn them once, and then they can apply that knowledge in subsequent usages and just navigate to that. Sometimes it's very hard to find the right icon, or even if you think you find the right icon, that icon can mean so many things. In this case, this can be a search, this can be a zoom, or it can be just a ping pong paddle. So again, know your target and always test the interface that you're doing. But having icons is something that will make your interface much easier to organize and digest after, not necessarily for beginner user, but for advanced user. They will know where to jump. These are just a few of the principles, and I don't know if you're passionate or not about this kind of things, but the UX field has, like, I don't know, like from psychological tips and tricks to things that come from visual arts, and it's such a diverse field, and that with very little information you can bring so much benefit for the end user. So yeah. I will want to ask to see some questions.
Okay, thank you, ma'am. We definitely have some questions, but ma'am, unfortunately, we are out of time. So you
Okay.
can address these questions in the chat box. And thank you, ma'am.
Yeah.
I'm sure this. Yes, ma'am.
And you can send the questions at my Twitter handle. And thank you so much for inviting me. And have a great day. Thank you.
Thank you, ma'am. I'm sure that this talk would have helped everyone in improving the UI and UX of their projects. Ladies and gentlemen, that was Ekaterina Moraru. We'll be having a small 5-minute break gap, and on the other side, we'll be joined by the great Mr. Greg Hartman with his talk on the topic, what kernel developers wish application developers would do better. So stay tuned and see you on the other side. This is your moderator, Rakshit. You can find me on Twitter by the hashtag, by the user ID @Dogra Rakshit. Signing off, stay home and stay safe. Thank you. Good morning, good afternoon, good evening, and namaste everyone. My name is Rakshit Vaishnavi Dogra, and now I invite Mr. Greg Crow Hartman, who goes by @GregKH on Twitter. I'm definitely sure that there is no need for an introduction. So, ladies and gentlemen, put your hands together for Mr. Greg Crow Hartman. All the best, sir.
Okay, is that working now? I hope so. Fun thing
Yes,
is,
sir,
I have
audible.
great. I have construction happening right below me, so we might hear some drilling in the background. But hey, this is the joy of working from home in this situation. Okay, my talk. Obvious title. It's actually really short. It's only one slide. If I can do this. There. That's the whole talk. Okay, let's go into a little more detail though. I'll try and explain why you don't want to make users mad and what happens when you do. A little bit about me, since it didn't introduce me. I've been a kernel developer for way too long. I used to be an embedded developer before that. I maintain stable kernels. I have done a lot of user space work, but at the low level, I also maintain some user space packages. I will make fun of GNOME later, but let me tell you, I have been advisory board for them for many years, and I'm still a foundation member. And I've worked on lots and lots of different distros. So all this stuff comes down to a pretty simple thing. Who are you writing code for? Are you writing code for what type of, why do you doing this? Why, it depends on why you're doing this, depends on what you should do. So, very simple. If you're writing for yourself, then it's not a problem. You throw it over the wall, you have fun, you put it out there, publish it. You want other people to see this stuff, get a resume. Wonderful, no problem at all. Don't care about anything. Don't worry about it. But the problem is, if you write something that's useful, it will come back and bite you. SSLay and OpenSSL was infamously created because the developer wanted to learn C, and all the problems that happened with that. One of the forks of UDEV was because somebody wanted to learn C again and put it out there, and people start relying on it, and they have to maintain it and use it. So if you do this, just watch out, because it can happen. If you're writing code for others, which I think everybody here is, because we all want to write open source software, we want people to use it, then we have to care about the users. And we have to care about what they think, what they do, and how we react to them. And we have to think about them when we create the software, within reason. There's the infamous XKAD document of somebody's odd feature. A bug was the feature. Everything I say here is within reason, because there are always some users you can never please, no matter what. And those people you can safely ignore. So let's start out. What you do and how you act on creating code depends on who you are. And I'll break everything down into about 3 different groups here. Kernel developers. This audience is not kernel developers, but since I am one, I'll talk about what we've learned and how we've made mistakes and what we've learned from that, and how to apply it again to library developers and application developers, which is the primary audience here. So first off, kernel developers. Easy thing. We only have really one rule. And Linus gets mad at this whenever you see rants in the press or whatnot. This is when we break this rule. And the rule is we cannot break user space. And cannot break user space on purpose. Break it accidentally, we'll fix it, whatever. We break user space if nobody notices, that's fine, because we take advantage of things that when you don't notice, different functionalities or stuff, but you just can't break user space. And we make this rule, and other operating systems have this rule as well. It's a very solid rule because we always want you to upgrade. And we want you to upgrade without worrying about it. We don't want you to feel scared if you see a new release and we say, hey, this fixes a bunch of problems. We don't want you to feel worried about taking that. And that's really, really important, especially with security. You want people to take all these fixes. You want people to be able to upgrade. You want them to also take advantage of the new features. And if you have them even hesitate about updating to your latest version because you've broken functionality for them, they won't. And that's not okay. Again, users, we've learned this the hard way. They will not update if they're afraid you're going to break it. And in the long time kernel past, we used to break things, and we now realize that is not what we should ever do. I'm going to have a few number of rules in this talk. They're not necessarily my rules, but I'll claim them for the choice of the talk. So the problem with never breaking user space is what do you do when you need things to change? The trick is you just support everything until there are no users. Figuring out when there are and are not users is up to you. In the kernel, sometimes we know that, oh, there are no hardware of this type out there. We used to have an architecture where we knew there was only 2 machines in existence. One of them broke, and the other one we actually paid the developer to replace it because we didn't want to support that thing anymore. Other bits of hardware we ripped out of the kernel when we knew things weren't even being used anymore. We just ripped some code out from Intel, that a device that they know is not in the field, that nobody actually uses. That's fine. But otherwise, we have to keep supporting users. Because we made that contract. We made that contract that we gave them a functionality, we cannot remove it. But what we can do is we can evolve things over time so that nobody actually notices. We can move to different ways things happen. We can do different things, how stuff works, and we can provide new ways of doing things. And if we provide new ways of doing things, hopefully people will migrate over time. In reality, they don't. They stick to the old stuff, which is fine, but we can provide new ways. And this is how we constantly evolve and how we constantly move forward. And this is how you survive, because you have to change with the world, so you have to provide new functionality. A lot of people, I get this complaint a lot from a number of people who have been in the IT and the computer industry for a long time, saying, well, how is Linux succeeding? It's an old model. The old Unix POSIX model is obsolete. We shouldn't be doing this anymore. And the problem is, in one way, Linux supports that. They support your binaries from 20 years ago, from 25 years ago. You can still run really old BSD applications, you rebuild them and they work. Or you can run your application that was built 20 years ago and it still works. So people think Linux is stagnated, but in reality, we've created new functionalities right next to the old functionalities, and that you can do different things. You can take advantage of stuff. We have eBPF, which is taking over the world. It's a microkernel-like architecture. You can run user space programs on the kernel. You can do all this fancy stuff, proven that you can't lock up the kernel. Wonderful stuff. IOU ring is fast asynchronous IO in a different way that has ever been done before. And it's, again, sitting right next to the old POSIX model so that your old programs can work just fine, but new programs can take advantage of this stuff and take advantage of speed increases. Of course, Linux now is a real-time operating system. It's been a real-time operating system for a while without a tree patch. Those changes are almost all merged. That's something people said could never possibly be done, but yet we did it right next to the existing operating system and nobody noticed. That's how you do it. You evolve and add new functionality without breaking anything. In order to do this, you have to create the trust that people can rely on. The kernel developers made this public promise 15 years ago, and we haven't broken it since. And that is how we're succeeding. Because if we break that trust, people will stop using us. And that's not okay. And we learned this really, really a hard way. When old development model, we used to have stable in the development trees, and the development tree would last a year, and the development tree lasted 2 years, and then almost 3 years, and it turned into a nightmare. We broke things, we had to roll things back, we had to make things work again, we had huge, massive forks, we all were working on different things at different times, and it was a nightmare. Then after 2.6 came out, a long time ago, we said, we're never going to do this again, and we're all going to be stable. Every single release we do is stable. So we've been that way since 2003, and it's worked. And people rely on us, and we've done it. People said, this is something you can't really do. We kind of proved that you can do this. We have a release every 3 months. It's stable. It's maintained. We have long-term trees that people want to stick to those for various reasons for certain hardware or products. But it can be done. And so I recommend that the stable model, rolling releases, time-based stuff works. So we've figured it out the hard way. Other operating systems have done this before. Windows infamously maintains backward compatibility. OS X does not. And you see OS X developers getting very mad about that. So it's a trade-off. Depends on where you want your operating system to be used or not. Along those lines, this is a big reason. Because we can't force anybody to use Linux because it's free. You can use it if you want to or not, if it solves your problem. But we should never create and give you a reason to stop using it once you used it. Once you use it and rely on it, we don't want you to be bad about it. We don't want to make a breaking change that keeps you, that causes you to move away. And that's something really important. If you write software, you don't want to alienate people and cause them to go away, hopefully, if you like users. Okay, that's kernel development. I guess we'll do questions at the end. So I'll wait. This is going fast. This is fun. So let's talk about library developers. I know there's a number of library developers here, and this is the hardest job ever. I really, really feel sorry for you. Libraries, writing a library develop is hard. It's one of the hardest things to do. In the kernel, we're really lucky because we have internal APIs that we can evolve and change over time. Because they're inside the kernel, we don't have to worry about breaking that. Once things go outside the kernel, I mean, that's all a library is. It's an outwardly facing API. It's impossible. And the main reason it's impossible is you can never know if your API actually works until you have a lot of people using it. And by the time you have a lot of people using it, then you realize all the problems with it, and then you can't change it. Getting it right the first time is almost impossible. It's hard. I don't know how you guys do it. It's a very difficult task. The few libraries I've had to write are horrible, and you learn over time. There's some good ideas on how to do libraries, but it's really difficult. Here's some good ideas. One thing is you can never break anything. If somebody starts using your library, you can't break it. That's just a flat out rule. You should not ever break that rule. Otherwise, you'll not use it. You won't have a user anymore. The only way you can fix things is by creating new ones. And when you create a new API, you can hope people move to that API, but you still gotta stick around and keep that old API. But in that API that you're creating, you need to be strict. You should not follow the Postal's law for APIs. It just does not work. We've seen it happen time and time again. If you accept things that are that are out of bounds or out of scope from what you think you should be accepting, and then you try and change that later on, you will break real users. So you need to be very strict in the beginning. In the kernel, we learned this the hard way with system calls. We had extra fields and other sections of ioctls and such that we didn't care about. And then when we wanted to increase things or add a new feature or change something, we all of a sudden had to accept that those fields would be full of garbage. And we couldn't do that. So we now have a rule when we add new fields and new system calls that we have, if anything is reserved or anything is reserved for future use, we check it. And we check to make sure it's set to nothing. And otherwise, we will break in the future and we'll have to create another system call. If you look, we number our system calls. If you have the third and fourth version of them, we have a number of those over time. That's just how things grow. So don't follow Postal's law when you're creating an API. You cannot maintain it over time. Just trust me. Look at glibc. They know how to do this as well. Slides. Oh, there we go. Rusty Russell is a kernel developer. Back in 2003, he gave a really good talk on how to create an API such that if you hate your users or if you actually like your users. There's 2 blog posts that he summarized it in a nice way in 2008, made it a little better. The original talk slides are really interesting. I'd recommend everybody reading it. And if you can find it, I couldn't find the link online. I think the talk was recorded somewhere, but it was from 2003. Read those blog posts. It tells you how to create an API that somebody cannot get wrong. And that's the goal. You want it to be so that your API is intuitive, is not hard to use, and is self-documenting, and all sorts of good things. Read those things. They're really good. So again, a lot of people claim that they want to move different APIs because they don't want to use them anymore, they're broken. You got to keep supporting them because you will have users. And you want to, if you do want to have people move to new things, you need to provide them guides and help and documentation for how to do that. You can't just throw a new API out there and expect them to use it. And you need to document this stuff. And you need to document it really well, because if you don't, Stack Overflow is going to try and do it. And we have so many examples in the kernel, at least. You see these common patterns get submitted to us and drivers and whatnot, and you're like, where is this wrong code coming from? And it's a Stack Overflow post that's been uploaded from 10 years ago with, here's how you solve this problem, when that's actually wrong. Downloading those and getting rid of those is impossible, so you just have to deal with that. You don't want Stack Overflow to be your primary use, your primary documentation. Provide good documentation. So in the kernel, now we have tons and tons of documentation. I don't know if anybody reads it, but we have it there to at least point people out when they get it wrong. We can say, go read this stuff. And that's the most important thing. But you need to provide a guide for how to do this type of stuff. And again, always evolve. I can't count the number of times I've seen deprecated in libraries, and you rebuild your code against a new library, and it's all of a sudden starts throwing you a bunch of warnings. That's the API, that's the library creator saying they give up. That's not okay. A lot of times you can they're saying use this instead of that, then do that in the library. work around those things, because once you have a user, you need to keep holding on to that user. I don't want to rewrite my code just because you updated something, unless there's a really, really, really good reason. And there almost never is. Please just work around it and solve the problem on your own. That being said, sometimes you do have to take a break. You do have to start over again and go on, but do that, and do that as a whole new library. GTK is a good example of they just started over, and that was great. And they different ways of doing things and different model, and you go from there. And that's a perfectly valid reason to do that. Hopefully support the old stuff because you have lots of users from that. Over time, it's nice to evolve things out of a way, but just start over. And then you have no users, and then you don't know if anybody's using your API. You don't know if you got it right until you have users, and then it's broken, and the cycle continues. That's life. That's the life of a library developer. I'm so sorry, but that's your choice. But it's very useful, very useful. But you need to, if you violate those things, you cause people to lose trust. If I see somebody, if I rebuild and see deprecated all over the place or APIs changed, then it's just horrible. You don't want to do that. You don't want to violate that trust on purpose just because you're a lazy developer, just because you feel like it could be done better, just because you want to change things. Don't do that. You're violating the trust that you're giving to a user. And if you violate that trust, you won't have that user anymore. And I've done this many times when I upgrade a library and it turns out my code that relied on it now has to change because of that. I will do everything I possibly can to rip it out and never rely on that library again. Maybe that's a good thing, maybe it's not. Usually libraries are there because I want to do something else, and a library is providing the functionality so I can do what I really want to do. I don't want to have to write the code that's in the library itself, but don't force me to. If you start breaking things, I will, and you won't have any users, and that's not okay. Please don't do that. Okay. Wow, I'm going fast. Application developers, a lot of application developers here. This is good. This isn't such a hard thing, but you guys are the most easiest to criticize, so I really feel sorry for this stuff. Everybody sees the buttons. Everybody thinks they can do something different. Everybody wants to criticize how the layout looks, what the graphics are. Look at the previous talk. Here's all these hints on how to do things better, and if you get those wrong, people get mad, and they'll get mad easily, and it's usually your core functionality of your application is somewhere else. It's not on these buttons. It's not this stuff, and people get upset. You're the easiest to criticize. It's just like a traffic engineer. Everybody knows where to put the road except you, obviously. So they will tell you about it and they will criticize you. And that's not okay. I feel very sorry for you, but here's some things you can do to do this. The biggest thing to do is don't take away things that work. If somebody's using this feature and using this functionality, keep it there. It's that simple. It was there, you provided it for somebody. Don't think by removing it, you're doing them a favor. You might be doing yourself a favor because you think it can be done a different way, but don't, because it's not going to work. And the biggest example of this, and the most public example of this, happened many, many years ago. 2011, the big date. A number of people here know what that date was. I have heard it talked by as this date, and this was the GNOME 3 introduction. Everybody's system instantly, when the distro switched it over, it looked totally and completely different. That was a major, major break. This was the day the GNOME project realized that they had real users based on the feedback they got. They always thought they had users. They always thought they were doing the right thing. They wanted to make a change. They wanted to do something different. But this was the day that they really broke all their users' trust, because all of a sudden they imposed a totally different model onto them, onto what they were currently used to doing, getting the workflow, and it broke them. It just caused a number of major, major pain. It was horrible. The LWN.net review of GNOME 3 was actually really good. It was very comprehensive, and the comments, of course, were horrible. But read these. If you're an application developer and you are considering rewriting how you do everything in a totally different way, look at this. You are seeing people mad because you took something that they were using to get their real work done. Their real work isn't to create a interface or application environment. Their real work is to do something else. And you made it harder to get them to do their real work. You broke their trust. And that was a long way. And the GNOME developers clawed back from that. It took them many, many, many years to do that. I think they're there now. I know myself, I switched away and came back many years. They've gotten better since 2011. They realized having a clean break doesn't work. And that was not the best idea. Please don't, in your application, do the same thing. I see this happen a lot. People evolve applications to do something totally different UI. That's not a good idea. Please don't do that. As a result, everybody here knows Mate and Cinnamon sprung up. They fill a real need. These are real desktops that are with lots and lots of users because they were used to it before, or they're used to that common paradigm. That's fine. But this is an example that kind of shows that what the GNOME developers did was major and was really big, because there's two separate projects to fill that void. That's fine if the GNOME developers wanted to do that, they did. That was their decision to do. Again, we're writing software for free. You're throwing it over the wall. I would say that maybe that wasn't the best decision to do. But hey, maybe you should have called it a different project, gone off in a different way. That's their decision. Again, be aware of this. It will happen. But you want to change. The thing about applications and IDEs and interfaces and whatnot, you want to change based on time, based on the world. We change because we have to change, based on different ideas, how things work. So there's really two acceptable ways to change in order to keep your users. And that is, you can evolve slowly so that no one notices. That's like the kernel. We add new features, we don't take things away. We do nice things, we evolve in such a manner that everybody's like, oh, that's just a common change. I have my common paradigm from before, I can learn the new stuff and keep on going. It's a constant evolutionary change. It isn't jarring, it isn't major, it isn't a whole new paradigm and stuff. And again, the best example of this is KDE. KDE has evolved and changed over time. If you look at the old model versus the new stuff, but they've evolved in such a way that the ideas are still there. You can still have the same features. You haven't broken anybody's workflow. You added new stuff. You maybe moved things around a little bit, made it prettier. Of course, things evolve over time, but you didn't break anybody. And because of that, you don't hear anybody complaining about the new versions that much. Right? They update to a new one. They're like, hey, it looks fancier. And they keep on going because they can get their real work done. And their real work is what they want to have done. So that's a really good way. KDE does this very well. GNOME, since the big break, has done it pretty well as well, if you look at their individual releases. But again, maybe they learned from KDE. I'm glad you guys are talking. Another way you can do this is if you provide a compelling reason to make the change. You have to provide enough reason and enough goodness to force somebody to take the time to learn to do something else. That's very rare. It happens very, very rarely in application space. Sometimes in library spaces it does. I'll call out systemd as a good example of how they did it right. They provided all the functionality. They solved a real problem that was there. They unified all these existing tools and problems in such a way that it was just so much better to use, and it provided enough impetus that everybody was willing to do the work to modify their own stuff and move to the new model. It worked. People still complain about it, but it worked. Everybody switched. Everybody had updated the new stuff that KDE is doing with systemd on how it launches better. It's very nice. GNOME was integrated with it from the beginning, from very early. It works well. It solves a real problem. Again, that was an example of how you can provide a compelling reason to move on and make the change. So again, never break somebody's trust. Or they will leave. If you want them to leave, that's fine. But realize they will leave if you do break that trust. And for my final rule, again, you don't want to make anybody mad. They will not be your users anymore. It's that simple. That's it. If you take anything, again, it goes back to my first slide. Don't make your users mad. And you make your users mad by throwing changes at them that they're not expecting so they can't get their work done. And that's all. That was fast. 55 slides in half an hour. So, questions? Anything else? How do I do this? Questions in the shared notes. Okay, okay. Big change in your application, do it step by step. Yes, again, evolve over time. Libraries, just keep adding to new libraries. Applications change things over time slowly, and keep the old paradigm, the old model. If you want to switch to something major, make it a whole new program. It's that simple. Symmetric semver, signaling breaks by changing major versions. I think it's pointless. If you're going to signify a break by a major version, just call it a new library. Just make it a new name. It's that simple, because you're telling the world, throwing everything away, you got to start over again. It's no different. Just support the old one, support the new one, and move on. Yes, I can understand if you don't want to make changes and move to keep the old API around, but you threw it out there, so it's your responsibility in a way to maintain that. I don't think semver is a good idea. It just, in reality, it doesn't work very well. Auto-contained projects in Linux world. We have the whole Flatpak, Snap, all that other stuff people are doing. There's other solutions with that. Docker containers. I mean, in a way, we have more solutions for this than anybody else has ever had for any other operating system. People are working on that problem. Or you link it all statically together. There are solutions to do this. I'm not in this area space. Talk to other people that are. I'm way below that, so I don't know too much about this stuff. Apple doesn't follow this at all. They change things all the time, just delete APIs. You don't see the same kind of upset about this. You don't see the developers. Are you kidding me? Apple's lost more developers over time than anybody else. Developers for Apple products are mad and they don't like it. And you see them complaining all the time. They are willing to put up with it because that's their business and that's their job. They don't like it. They don't like it at all. So I think Apple's providing a disservice by doing that. Now I know why Apple wants to do that, because it's hard to keep things around for a long time, but to say that it doesn't cause problems is naive. It does cause problems. There's tons of blog posts about it and arguments about it, and how old applications don't run anymore, et cetera, et cetera. It's hard. Apple's big enough and they throw their weight around and they can get away with it. But they don't care about their developers as much as they care about their users. Sorry. Any kernel technology, user space devs? Yes, I/O U-ring. User space developers who care about I/O should pay attention to that. I know the Postgres developers are looking at it now. Other database developers, it is asynchronous I/O with no system call overhead. Very, very fast I/O. You can throw things into a ring and you get notified in user space when your data is there. Very, very good if you care about I/O. I recommend looking at that. eBPF if you care about networking and networking control planes and stuff like that. And tracing and modifications of the kernel as it runs. eBPF is great. You don't have to write kernel modules anymore. You don't have to write drivers anymore. You can do some really cool stuff. eBPF just keeps getting better and better. There's eBPF conference last week. So go look at the notes for that. There's a book now about it. It changes all the time in the kernel, but it's really, really, really good. Again, that's what's exciting in Linux development. You should pay attention to. Linux is boring. We just provide a unified way to look at all your hardware. We support all the hardware, but we do so in a boring way that for an application you shouldn't care, because it doesn't matter what hardware you run on. That being said, new things, new system calls we provide, take advantage of those. We add a new system call every other release or so to solve some problem. Usually they don't get added to the library, to the libc quickly. You can take advantage of it on your own and use it in your application and roll back if you don't. You can test if it's there or not. Those are good things. I've proposed a few system call recently, but I don't have any actual users for it, so it doesn't get merged. So I need an actual user for it. So that was to do read and write of small files really quickly. Or read files quickly, not writing. What happens when the change you're up to is only important for the new users? Great, we add support for new users all the time, and you want to support new things, but don't break old users. That's the trick. It's sometimes a little different, because I know there's lots of applications that have been around for forever that have really old UIs, but they keep those old UIs in an old UI model because they want to keep those old original users, because that's what made them successful. And you can switch and add new properties and new things for new users as well. It's hard. I'm not saying it's easy to do. But this is why you're writing application software and not kernel software, right? Because you like doing this type of stuff. Just at least be nice to your users. What's the best way for our developers to stay up to date on kernel tech? Linux Weekly News, lwn.net. You can subscribe to it. They're a great organization, or you can just wait 2 weeks and the articles come out after that. If you're 2 weeks behind on latest kernel development, you're perfectly fine. So I recommend doing that. That's the best way. That's how we all know things, what are going on. We all read it as well. I think I answered all the questions. Anything else? No.
Oh man, what a talk was it? What it was. Thank you so much, sir, for the great talk. I'm sure
Okay,
that
I got to answer this last question. The color-coded
there is a
books.
question.
During the first Corona breakdown, I live in Europe, or lockdown, my daughter had to come home for university, and I'm in the little library. She color-coordinated the books to be for her conference calls, for her university talks. I didn't color-coordinate the books. She did that, so it was very Instagrammable. I take advantage. I give her full credit for that effort. It makes a pretty background. Sorry. Okay.
Thank you so much, sir, for this great talk. I'm sure that this talk would have enlightened and open source Linux developers. Ladies and gentlemen, that was Greg Crow-Hartman. And some important things that I want to tell you. Do not miss our breakout session today starting at 1:10 UTC. 13:10 UTC, and also the office hours of our champion sponsors, Canonical and Collabra. Secondly, our first social event, Amalfi Coast 2, will take place tonight at 2100 UTC in the main track. It will take us virtually in one of the most beautiful places in Italy and Europe. Oh man, how I wish I was there. Also, a big thank you to all our sponsors, starting with Collabra, Canonical, CodeThink, Red Hat, and Elementary. Have a nice break. See you soon.